Hello, everyone. I'm Sarah Hu. We're going to go over lesson 3. It's going to pick up from last week where we did a lot of work in base R, modifying data frames. And today we're going to be introducing the world of tidyverse. Okay. So this is my, I've opened up RStudio Cloud. I'm in lesson 3 right now. I'm going to open this up. And the first thing that you'll see if you don't have tidyverse installed is in RStudio Cloud, you'll see this message come up because one of the first things we're going to do is actually load the tidyverse package. But before we do this, there's a couple different ways to install packages. This makes it really easy because I'm going to hit install here in a second. But another way to install packages that's more common is to use the command install.packages and then in parentheses put tidyverse in quotes. So if you're working in R in a different format, this is probably the most common way to install a package. Right now I'm going to install this, and hopefully that will see it's sending install.packages down to my console here. So that's going to take some time, and during this time I'm just going to introduce tidyverse briefly. Tidyverse is a series or collection of different R packages that's been developed by the same group. And like what's unifying each of these packages is a very specific syntax or R grammar, basically, and these packages share that, which makes them really easy to integrate with one another. And it's the most common, all the things that are in tidyverse are the most common packages that I use. Ella, do you have a comment about tidyverse?
I was just saying that it makes your life easier, a lot easier. Once you get used to the syntax, it's a little different from what we talked about with data frames last class, but you know, it's just a matter of habit.
Yeah, and I think a lot of us were talking about during office hours last week, and I fielded some questions about apply statements. I use apply statements, but I more commonly use things in tidyverse, and I usually don't end up using a lot of apply statements for that reason, just because I'm more well versed in tidyverse. So this is continuing to install. Hopefully that's what yours looks like. One thing that we're going to do is we're going to import this test data set, which is listed here. I'm going to show you really quickly what that test data set looks like on my computer, both in Excel and then in a text editor. This is listing a name of taxa as a MAG identifier, and then we have the count information for 4 genes that have been pulled out at random.
Hey, Sarah.
Yeah.
What does MAG stand for?
Oh, MAG stands for Metagenome Assembled Genome.
Okay, cool.
So there's other groups in the BBCN network right now that are going over metagenomics, and this is just some test data set that I got from a collaborator who was running some of this, and I thought it would be an interesting test data set to use in this R lesson. All right, so this has been installed now. And so now we can actually execute library tidyverse, and then it will load. This is tidyverse always like, these are all the packages that it installed. So as a quick example, ggplot2, which we'll go over soon, and dplyr. You could also install just ggplot2 or dplyr on their own for some reason, but tidyverse installs just everything. Now we're going to import that test data set. My variable has shown up over here, and we'll take a look at it in a couple of ways, right? I showed you what it looks like in Excel and in a text document, and this is what it looks like when we look at the gene underscore data using view. So one question that I wanted to address was about different data frame versus a matrix. This is a data frame, which we can figure out from using class. This is printing the first 6 lines. And then the reason I know it, the other reason I know it's a data frame is that when we look at the structure of gene underscore data, we see that it's made up of factors and integers. And so data frames combine different data types in one R object, whereas matrices need to all be one value. And so I'll show a quick example of that as well coming up. So first, tidyverse lesson. Notice this way that I imported this data was using read.dlim, which is the most common way that I import data from a text file. But the tidyverse way is using read_dlim. And so we'll kind of see what happens when I use a tidyverse specific function. And this actually introduces the different parse columns that are imported. And now when I execute class, it lists different attributes of the object that I've imported. This is what it looks like using head. And what this is called is a tibble. And this is, I'll be honest, I more commonly work with data frames and matrices. And tibbles are a specific form of a data frame in tidyverse. It has different features to it. We're gonna primarily stick with data frames today, but I'll gloss over a couple of tibble things, and we plan to go over that in a future lesson. Back to what I was mentioning about the matrix option. This function here, I'm importing my gene_data, and I'm changing it as a matrix. And I just wanted to show you what that looks like. So in this case, everything's been turned into characters because I had a mix of text that was originally as a factor in the data frame format, and then I had integers. And so the only way R could resolve having both numbers and text was make everything a character. And so that's my example of what happens when you convert things to a matrix and it requires a single data type throughout the entire object. And again, even if when I do view, it still has the same structure that I had previously. Okay, so you've seen a lot of these same commands previously when it comes to exploring what the data frame is. And so, right, call names and the object in the parentheses reports all of my column names. And one thing we notice is that the output from this, the last gene listed is gene_D. And that gives me an alert personally. Ella, maybe you can comment, but I like to have everything have a very similar format here. So I would prefer gene to be listed as gene all capital and the D also be capitalized in this instance. So for this, I'm going to actually use calling it a typo, and I'm going to use this call names feature to change the last column to capital gene D. And so this format lists the call name, it selects the column, which is 6, and changes the column head to gene D. And so if we look at my column names and I count over 1, 2, 3, 4, 5, 6, this is the column I'm changing. So that's how gene D does that. And then if I print out call names again, now we see that gene D's been fixed. Now, as an example, if I wanted to change column headers 4 through 6, 1, 2, 3, 4, 5, 6, this is how I would do it, where I have call names listed, select the columns, and then I make I concatenate a list together of what I want those new column headers to be. And this is all, so just a quick reminder, this is all using base R right now. So let's execute that, and we'll again check the output, everything checks out. And the other thing is, for instance, if I wanted to export this table and show the order of genes, right now I have gene A, C, B, and D, but I'd rather it be A, B, C, and D in alphabetical. And so to change the order of columns, I'm going to show you a couple of different ways. This first one in base R, I'm setting gene data equal to a new object, and then I'm actually in brackets, okay, I'm selecting which columns. And in the process of selecting those columns, I'm selecting them in the order that I want them in. So recall that comma designates within the square brackets the rows and columns. And so in this case, everything's falling after the comma, so it's going to be selecting just columns. And so I'm selecting taxon, mag, and then the genes A through D. And so we'll execute that, and I'll check it here, data reorder. And in this case, we now see A, B, C, and D. Now, another way, going back to gene data, another way to reorder columns is to actually use the number of columns, right? So we know this is 1, 2, 3, 4, 5, 6. And so this is an example of that, where I'm taking gene data, and within my square brackets, I want to select columns 1 through 3, which is 1, 2, 3. And then I want to select column 5, which is B, and then column 4, and then 6. And so this is the order that I put it in. And those are, again, combined with commas listing everything. And so now when I look at this reordered, it's the same thing. And I wanted to show you these two examples in base R because I think about how these scripts are reproducible. And this option 1 here, when you're actually listing the columns, while it's more to type out, it is more reproducible. So that's just one thing to that I wanted to comment on, because in the future, maybe you want to add on another designation of taxonomy or something, or another attribute for a mag, and then these numbers would be not be applicable if you want to rerun this code. Ella, anything to add on about base R renaming or reordering columns?
No, I think you covered it, and we discussed some of it last time, so we're good.
That's true. I think I wanted to hit on these because now we're going to change our world and do the same things in tidyverse. So I'm going to re-import this data. So we're starting again with the data. We know there's a typo. We know that we want a different order in the columns. So I've imported that. I have a tendency to do this a lot and check what the output looks like. So recall I had fixing that last column, column 6, changing it to gene, capital gene, and then a capital D. And I'm actually going to do that in tidyverse now. So I'm going to, this is the syntax for tidyverse, where if you want to set to a new object, this is very similar. You put the object's new name on the other side of an arrow and a dash, and then you input the data frame that you want to change or modify, and then you use this called a pipe. So this is a pipe operator that will kind of be it's the structure of the tidyverse syntax, or kind of like brings all the tidyverse commands together. And so, and we'll go over, you'll see the use of these as we go along in the full lesson. And then I'm using the function rename within tidyverse. So I'll quickly pull up rename here, but rename does exactly that. So now that when I execute it, and then I can actually look at the call names for gene data fix. Now I've changed my new column header, capital G, capital gene with a capital D, was equal to that previous column header name. So this is how I'm kind of renaming it, by setting a new column equal to what that previous column was. And that's how we're using the rename function. And then, so this is now showing, that's the tidyverse version, and the tidyverse version of reordering a set of column headers is very similar, where I'm actually selecting those columns, and it's doing the same thing, where now I'm using gene data fix here, and then on the other side I have a new pipe, I have select, and here I've listed the column headers that I want reordered. So now when I do that, we again have my gene names in the order that I want, and they're also capitalized. So we're going to go into, get a lot deeper into tidyverse this week, and likely next week, and we'll talk about how we work to string these together and build more complex commands using these packages.